In a previous video, you learned how to find the second derivative and the third derivative of a function. Well, now we're going to be looking at how you use implicit differentiation to find that second derivative. So at the end of this lesson, you'll be able to find the second derivative of a function using implicit differentiation. And we are just going to do one example. Please remember previously, hopefully you remember that I told you that when you see this weird looking symbol, that just means that we're going to find y double prime. So we've got our equation. Hopefully we're somewhat familiar with using implicit differentiation now, so that's exactly what we're going to do. The derivative of x squared will be 2x, and then the derivative of y squared will be 2y dy dx, and then equals the derivative of 25 is 0. Okay, solving for dy dx, we'll subtract 2x from both sides. So we'll get 2y dy dx equals negative 2x. And then to solve for dy dx, we'll divide both sides by 2y. So now dy dx equals negative x over y. So that's the first derivative. Okay, so now what we want to do is to find the second derivative. So first of all, I noticed that on the right side we actually have a quotient happening, so we are going to need the quotient rule. So I will let the numerator be the f, and we'll let the denominator be the g. So now using my little side step, f prime, the derivative of negative x will be negative 1, and then g prime, the derivative of y will be 1, but then don't forget we're taking the derivative of y with respect to x, so we do need to write dy dx. All right, so now we're ready to take the second derivative. So now I'm taking the second derivative. The left side, when you take the derivative of dy dx, you actually get the second derivative. So we're actually going to write that fancy notation. We'll get d squared y dx squared. Okay, and you could also write y double prime, that's fine. It means the same thing. Right, the next thing that we're going to do is use the product rule, the quotient rule, excuse me. We have f prime times g, so negative 1 times y, minus f times g prime, so minus negative x times 1 dy dx, all over g squared, and g squared would be y squared. Okay, now I'm going to clean that numerator up. Negative 1 times y will be negative y. A negative x will be plus x dy dx over y squared. So we basically have found the second derivative. The big thing on this one though is usually they'll say to find the derivative in terms of x and y. So notice I have x and y's, but I also have this dy dx, and so we don't want that dy dx there. So there's something that we need to do with that. Right, so this is what we're going to do. You'll notice up here for the first derivative, we actually know what dy dx is equal to. It's equal to negative x over y. So what I'm going to do with this dy dx is we're actually going to replace it with what I found it was equal to. So this will equal negative y plus x times dy dx we found out was negative x over y. And it's still all over y squared. All right, and I'm going to move over to the left side of my screen here and see if we can clean that up a little bit. So I'm going to have negative y. I'm going to put a 1 underneath that x because then remember you just multiply straight across. I'll get minus x squared over y all over y squared. Okay, notice we have a complex fraction, which is really not allowed in math. So the next thing that I'm going to do, hopefully we're somewhat familiar with complex fractions, I'm going to put a 1 underneath the y, and now notice the common denominator of these two parts would be y. Okay, so on this one, I would actually have to multiply the numerator and the denominator by the y, so I'm going to get negative y squared, and this one I wouldn't need to multiply by anything, so we'll just say minus x squared. Okay, it's still all over y squared. So now notice I have a fraction divided by another fraction if I put a 1 underneath there. So remember now we can multiply by the reciprocal. So the reciprocal of y squared over 1 would be 1 over y squared. Okay, and then finishing this up, if I multiply straight across again, I'm going to get the second derivative is equal to negative y squared minus x squared all over y cubed. And at that point in time, I can be done with my problem, and that is my second derivative. So now hopefully you can use implicit differentiation to find the second derivative of a function.